Hello, this is STEM with Sid. Welcome back to the channel. Today I'll be going over the tangent line problem and differentiation. So basically, remember when I explained what the tangent line problem was in one of the earliest videos that I made? It's pretty much how I find an instantaneous slope at a particular moment in a graph, right? Now, if you're just looking at like a secant line, which is a line that passes through 2 points of a graph, let's say you have something like this. And, secant line could be something like, here, let me draw this better. Something like, I don't know, this, right? 2 points. To find that slope, I hope everyone remembers that it's just change in y over change in x, right? So let's say f of x plus some, delta x minus f of x over x plus delta x minus x. Obviously, these cancels out. So the change in x minus, is the x to change, and then the change in y, right? That is how you find the secant line. However, for a derivative, you're trying to find, like, let's see this graph. It's 1 point. Tangent line is at 1 point. So not secant line, tangent line. So what do you do at that 1 point? Well, you can still apply the secant, slope formula to it. Gets a little trickier, but still doable. So basically, there are different forms of, a derivative. It can be written as, f prime of x, right? If f of x is your function, dy dx, as well as even capital dx, like that. Now, I'm going to use dy dx because that's like the common way to use it. But dy dx, which is the derivative, is equal to the limit of delta y over delta x, because that's what a slope is. A derivative is a slope of the tangent line, right? The tangent line, whatever the slope is. So how do you do it for like 1 point, right? Well, it's actually not 1 point. It's like 2 points, but they're very, very close to each other. Like close enough that the distance between them is approaching 0. So that's pretty much what it is. Limit of delta y over delta x. That's actually where the d's come from here. Delta y over delta x as delta x approaches 0. So if you, use this limit, right? Same thing as I did in the secant line, f of x plus delta x minus f of x over delta x as delta x approaches 0. That equals f prime of x, or, dy dx, right? So that is the definition of a derivative. That is literally the definition of derivative. And you can use this to find derivatives of functions. So I'm going to, use this to do some problems right now. So let's scroll down for a second. Let's do derivative of, and later on I'll show you a quicker way to how to solve these, but for now, this way is a very good way to understand the basics of derivatives. So x cubed plus 2x. For that, f prime of x equals the limit delta x approaches 0 of what? F of x plus delta x minus f of x over delta x. Now I'm going to scroll down. Now you just pretty much plug this in to the function. So you're going to get the limit. Now I'm not going to write all these steps because it'll take a while for me to write, especially on a computer. However, you just do x plus delta x cubed minus 2 times x plus delta x. And then you subtract this part of it, right, which is just x cubed plus 2x, right? And then all over delta x, right? Now, this cubed is literally just, this part is just x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed plus 2x. I'm just basically not factoring the opposite. I'm like foiling everything out here. So plus 2x plus 2 delta x minus x cubed minus 2x. This is all over delta x. And remember to keep your limits. That's the important part. Okay? Now, I'm not going to show all the work, but eventually, if you do the math correctly, you'll get to this step right here. Delta x will be at the top with, well, if you're doing it a certain way, but 3x squared plus 3x delta x plus delta x squared plus 2. And actually, this makes sense. Look, these cancel out, these cancel out. And what I did just now is just factor the delta x out of all of these, right? And then there's still the delta x at the bottom. Cancel these out, right? Now, delta x approaches 0, right? So this is going to be 0. This is going to be 0. What do you get? 3x squared plus 2, because delta x isn't x. Delta x is delta x, right? So you're going to get 3x squared plus 2. This function right here is the derivative of x cubed plus 2x. The derivative of f, basically, so we can say now that f prime of x is 3x squared plus 2. That's exactly what we got. Now, that was a linear function, right? Because if you, sorry, that was not a linear function. I'm sorry. That was not a linear function, right? X cubed plus 2x. But we were still able to find the derivative of that graph, right? So, if you have a graph like 2x, right? What do you think the derivative of this is? It's just 2x. What's the tangent line to this? This is the tangent line, right? So the slope of the tangent line is just 2. So you can say y prime is 2. Okay? Now, let's do one where it is a linear function. Let's do, because this is a non-linear function. So I gave an example of a non-linear function, and this is a little too easy of a linear function to do. Y equals 2x. Let me just complicate it a little bit so that we can do one like that. But it's essentially the same process. Let me erase this. It's just the limit process, really. The limit of f of x plus x minus f of x over delta x as delta x approaches 0. And you just cancel out terms until plug in your 0, right? Until you get your derivative. So let's do one more example for this. F of x equals 2x minus 3. So, you got limit of delta x approaches 0 of f of x plus delta x minus f of x over delta x. And this equals, I'm going to not write the limit here to save time, but you should always remember to, write your limits. So, you will have 2 times x plus delta x minus 3, and then you can subtract 2x minus 3. Oh, sorry. You'll have something like, sorry, let me undo that. Okay, like that, okay? All over delta x. Now, in this minus 3 minus minus 3, which is just 0, so these two cancel out. This will be minus 2x. At the top, you'll get 2x plus 2 delta x, right? Because just distribute. And then this part's just minus 2x, right? So I'm writing this as minus 2x plus 3, right? This minus 3 plus 3 cancel out, and then the 2x and the minus 2x cancel out. So you're going to get 2 delta x over delta x. And I will just write this last step, but you know what the last step is going to be. Limit as delta x approaches 0 of 2 delta x over delta x. Cancel out the delta x's, and you get 2. So the derivative is 2, and that makes sense because that's the slope of the tangent line. Tangent line of which one? The function that I had here? Yeah. 2x minus 3. Sorry, right here. So we can say that f prime of x is 2. Lastly, one more subtopic in this topic. So one thing you need to know is that differentiability implies continuity. But it's not the other way around. So if something is continuous, if something is differentiable, it is continuous, no matter what. However, if something's continuous, it doesn't necessarily mean it's differentiable. I could give you a simple